Welcome to Algebra 1, Semester 2, Unit 11, Section 10.8. This is our very last video for this class. So proud of you guys that have kept up on it and are finishing it up. We are going to look at comparing linear, quadratic, and exponential functions today, and through class we are. You have an opportunity to choose your pay at the next job you take, which is the better deal. Pay number 1 is $100 a week with a $5 raise each week thereafter. Pay number 2 is $100 per week with a 5% raise after that. So we come down and we make a T-chart of what would happen. With pay number 1, it was a $5 raise each week, starting with $100. So we start with 100. End of the first week we have 105. End of the next week it's 110. Third week 115. Fourth week 120. Fifth week 125. Sixth week 130. Seventh week 135. Yeah, you should already be starting to think, is that linear, quadratic, or exponential? We're adding 5 to each term. On the next one, we're going to get a 5% raise. So 5% is the 100% that we already earned plus 5% more. So it's 100% plus 5%, which would be 105%. Change that to a decimal, we have a growth rate of 1.05. So in the calculator, what we'll be doing is taking the 100, multiplying it by 1.05 raised to whatever the week is. So in case you want to see how to do it in the calculator, you would go, turn it on, then you take 100 multiplied by 1.05 raised, for the first week it'll be raised to 1, enter. Sorry, did something wrong looking to the camera. Okay, so we take 100 times 1.05 raised to the first equals 105. Okay? So they're the same the first week. Now, in the second week, as we multiply that out, put it in the calculator, you get 110.25. We won't put decimals in here. So the third week, it actually comes out to 116. The fourth week, we get 122. The fifth week, we're at 128. Sixth week, 134. Seventh week is 141. Now, if we go clear up to the 10th week, we start to really see the curve come in here. The 10th week, for pay number 1, we're at 150. But for pay number 2, we're at 163. Okay? And it just keeps getting further and further apart. So we put our weeks down here on the graph. Go ahead and graph this. We have 0, 1, 2, 3, 4, 5, 6, and 7. Then for the dollar amount, let's put a break in the graph here that shows that we're skipping. It's not going from 0 to 1, so it's going to start at 100, then 105, 110, 115, 120, 130, I'm sorry, I went by tens there, 125, 130, 135, 140, 145, and that's higher than our data goes. So now, for the first one, on day 1 it was 105. Well, they both started at 100, and then at the end of week 1 it was 105, 110, 115, 120, 125, 130, 135. And then you should use a ruler and connect those. What kind of a graph is that? That's a straight line. What kind of function? If you're saying linear for pay number 1, that would be correct. So just write pay 1 and put linear. Now for pay number 2, we go 100, 105, 110, 116, 122, 128, 134, 141, and then if we extend it on out here at 10 weeks, it would be up here at 163, so it curves considerably after that. So connect those with a nice smooth curve, not with a ruler. And what would that one be? Should have spotted it right here when we put the variable in the exponent. That is an exponential. And you'll be doing a few more models in class with that one. Next page, we're going to look at what each of these parent graphs look like. If you remember right, linear, just like that. It went up an equal amount, a constant amount the whole time. Exponential growth went like this. That was growth. And decay, we'll make it a dotted line. It went this way, decay. So you can have either one, decay or growth. Quadratic, remember it's at 0, 0, comes up 1, 1, and it is a mirror image of itself across that y-axis. It looks like that, okay? Thinking about each type of function completes typical sequence patterns that you might see in the function. Well, remember from previous labs that we've done and notes that linear we always add the same amount. It's a constant amount that we add. So in a sequence, we call that an arithmetic sequence. It would be, for example, 7 plus 5 is 12, plus 5 would be 17, and you're going to add 5 to all these. So 22, 27, 32, 37. You just keep adding 5. That's a linear sequence. You can see it by a common addition or common difference right there. Exponential, let's say we started at 7. Well, remember on it grows exponentially, so we take and we multiply by a factor. This one has a common ratio. Now, it could go up or it could go down. This is a growth factor that I'm doing here because it's going up. So 14 times 2 would be 28. They've all got to be times 2 now. 56. 56 times 2 is 112. Times 2 is 224. Times 2 is 448. Okay? So that's the exponential growth. Now quadratic, you would see it coming down like an exponential decay. It would be dropping down significantly, like 8 divided by 4 is 2, 4 divided by 2 is 2. But the thing with quadratic is it can hit that 0, and then it can come back up. 2, 4, 8. And it'll be mirror images of itself, usually. Not perfectly with all data. Like we'll be looking at rates of cancer, different things that way, where you won't see it perfect, but you'll see it go down and then come back up. Label each of these scenarios with exponential, linear, quadratic, or none of these. a salary that is $40,000 a year in the first year on the job with a $2,000 raise every year thereafter. So you're just adding $2,000 every year. When you're adding a constant, that is a linear. A salary of $40,000 per year with a 1% commission. Well, 1% commission is 1% on something else that you make, not on this $40,000. So that's nothing, neither. Because sometimes you might make money and get a raise, other times you might not. Or none of these, I guess we could have written. Salary of $40,000 per year with a 10% raise. That's up on the $40,000. So that is exponential. Housing prices fell 10% per month until 2008, then they began to increase at 8%. Here we see it's going down by a factor, then it's going back up by a factor. Like I said a minute ago, quadratics aren't perfectly symmetrical always when it comes to real life data, but you do see a factor drop and a factor gain, so that is quadratic. Okay, this was the last section for this unit. You will come to class tomorrow. We'll do some bookwork, some worksheets. These are the worksheets, don't lose them. And you'll have this packet finished off, and then I'll discuss with you that little final project as the assessment for it. Thank you very much. Have a good day.